Hello, and thank you for joining us today for our webcast, Splunk and EnCase, Operational Intelligence Meets Forensic Security. My name is JJ Cranford with Guidance Software, and I'll be your host and moderator for this session. There is a constant bombardment of alerts from perimeter defense and SIM tools. And today, it is a difficult yet critical job identifying and responding to all legitimate threats. Having comprehensive visibility into endpoint threat information is crucial to securing data. So at Guidance, we think it is extremely important for security teams to have continuity between their security tools and have solutions that work well together. Today, we will be taking a deeper look at EnCase Endpoint Security, Splunk Enterprise, and the integration between those tools from a technical as well as a conceptual perspective. And after that discussion, we will wrap up with a question and answer session. Joining us today to discuss the EnCase and Splunk integration are Megan Gardner and Mitchell Bazina. Mitchell Bazina is a principal solutions consultant at Guidance Software. He has over 14 years experience in information security and endpoint forensics, with hands-on experience in security and digital investigations of every kind. He has designed, developed, and implemented operational policies and solutions for digital forensics, e-discovery, and cyber incident response departments to gain production efficiencies and comply with business requirements. Prior to working at Guidance Software, Mitchell managed forensic and e-discovery consulting teams handling global investigations and litigation matters in intellectual property theft, employee misconduct, fraud, cross-border allegations, court orders, regulatory inquiries, and discovery requests. Megan has been a consultant with Guidance Software since 2014. She specializes in NScript integrations, customizations, EnCase endpoint security, Tableau, and EnCase plugin architecture. Most notably, her custom Splunk integration has been included in EnCase endpoint security. Megan has her EnCase certified examiner certificate and graduated from Queen's University with a Bachelor in Science in Computer Engineering. So before we get right into it, just a couple of housekeeping items. We have our EnCase endpoint security product brief freely available in this webcast, which provides details on our product offering for endpoint detection and response. It can be downloaded using the resource widget at the bottom of your screen. As always, we appreciate any and all feedback on our webinars, and we ask attendees to complete the survey that is populated in this webcast so we can continue to provide the kind of content our viewers will appreciate and find useful. At the end of this webcast, we will have a question and answer session. If you have any questions during the presentation, please submit those questions electronically using the Q&A window on your screen, and Mitchell and Megan will address as many questions as time permits at the end of the webcast. For any unanswered questions, Guidance can be contacted at experts@guide.com, through our website, guidancesoftware.com, or by calling 866-229-9199. For those of you unfamiliar with Guidance Software, we are the makers of EnCase, and we invented the space of digital investigations in 1997. We brought the first incident response product to market in 2006, and we have continued innovating in the market by leveraging forensic level visibility and control to solve problems for which such visibility is critical to incident responders and cybersecurity professionals globally. And now with that, I'd like to turn it over to our presenters.
Thank you, JJ. So we're just going to start off a quick agenda. We have quite a few attendees on the phone, and many are familiar with EnCase and Guidance Software, but not all of them. So we're going to start with a brief overview of EnCase endpoint security. We're then going to bounce into an overview of Splunk and the integration, and then go through a demonstration of the actual integration between the two products. So we'll start off with the overview of endpoint security. So what we've noticed here at Guidance is that over the years of doing incident response, things have changed a little bit. We've started to build a fair amount of large perimeter walls, stopping those advanced threats or stopping those advanced threats that we largely know about, but there's still a large amount that creep through, unfortunately. And what we've seen through statistics is that 90% of attacks that break into the news daily are generally unknown. So they're new attacks that have never been seen before, at least, or a variant of a previously seen attack that a policy or signature doesn't apply to. So the mean time to detection is generally quite high, where an actor has been in an environment for 206 days, based on the data that we have through various reports, before it's actually been detected. And then on the flip side of that, once it's been detected and an alert has been created, generally, and the team is actively involved in responding, it's generally a 21 to 35-day process in mean time to resolution. And this is obviously way too long. Once you know somebody's in your house, it takes 20 days as a minimum to get them out. That's a common problem we're seeing across the consortium of customers that Guidance have and many in the industry itself. So our goal here is essentially to reduce that time. And not only reduce that time from a large team perspective, but also a technology perspective, enabling teams to detect breaches in as short amount of time as possible after they occur, and then, of course, to reduce that breach resolution time, so once that detection is available and a specific breach has been identified, to actually resolve that as quickly as possible. And that's obviously a combination of items that we allow you to hunt for and identify in terms of outliers and breaches that are found, but also in breaches that are identified by other technologies. So some of the common problems we see across our customer base are very similar. So one of them is visibility, and visibility is a hard thing because many of us have security tools in place that give us network or perimeter visibility, some even endpoint visibility. But the ability to do simple things like verify security policies are actually working and running, see if an individual hash value for an executable that was found to be malicious is located in any other part of the environment. Those simple tasks sometimes are very hard to do depending on the technology in your workplace. So they're some of the common problems we see. We also see a large potential risk of undiscovered threats. So a lot of the C-level community and directors in the security teams are being asked, are we safe? Are we going to become another media phenomenon? And the simple answer is, for a lot of teams out there, is I'm not sure. And largely that's built around essentially us working in a passive security environment where we've built the walls up, we trust those walls are stopping the majority of attacks, and then unfortunately when one does break through that wall, we don't have the right visibility to see something that has come in. And with the endpoint being a piece of that, the endpoint is actually in a great location. So an attacker coming in is going to at some point access an endpoint if they have deposited malicious files or a remote access Trojan or something within the environment. No doubt they are using an endpoint. So if it exists on the endpoint, it's bypassed any security or perimeter controls that are in place, and now we just need visibility into the endpoint and the capability in order to identify those advanced threats, and then, of course, respond to them. And then the last challenge that we see fairly commonly is the large number of alerts generated by security technology itself. So most security teams are dealing with hundreds or sometimes even thousands of alerts per day. Those alerts are prioritized using policies, and then even those prioritized alerts need to be investigated, and the time it takes to get through each of those alerts on a daily basis is rather significant. So we've got essentially a three-pronged approach to handling the security challenges that we see. The first is providing another means of detection, sort of a last man in defense, so to speak, that essentially allows you to gather endpoint data. Data that's gathered is tiny, but across the entire enterprise. That then allows you to correlate machines against themselves over periods of time, and also machines against other similar machines to identify process and user-based anomalies. Once those anomalies have been identified, essentially we have provided a capability to respond, and not only respond to threats identified by us and potentially missed by other tools or security tools, but also respond to alerts or security events from other security tools. We do this through two approaches: an automated approach that allows us to take a feed from another security tool and automate a response, but then also a manual approach that allows you to deeply and thoroughly investigate a machine remotely and quickly. And ultimately, that response mechanism allows you to reduce the time it takes to triage security events down from hours, days, and sometimes even weeks, simply down to single-digit minutes, which is a huge time saving. And then the third area is recovery. So rather than taking the age-old approach of wipe and reimage, surgically remediating a malicious process, removing its persistence mechanism, and then scheduling that task to reoccur up until the point in which AV is updated and can continue on with that process for you. So again, just reducing the time it takes at each of those stages, hopefully giving you better visibility within your enterprise to hunt and identify for unknown threats that actively exist within the enterprise, and then recovering back to a trusted state. So getting into a little bit more detail, we're not here to talk about our detection capabilities today, but essentially what we're doing is we're looking for outliers and aberrations outside the norm using a baseline of a system. That baseline compares that system against itself over time and against other similar systems within the network. And essentially the way this is done is by using data from a snapshot in time. That snapshot goes very deep into information stored in the memory, such as running processes, map DLLs, open ports, communications from that individual machine, and brought back to a database where it can be referenced and provided in a dashboard type view based on the customer's internal environment. So each deployment of this solution is customized to that customer environment. That allows us to see those outliers that many other tools cannot. And then moving into the response section, it's very important to note that the reason that we have that average response time and even the detection time at such large increments, 206 days and 21 days for response, is because a lot of the process today is manual. So if we think of a security event coming in and maybe that event being missed, such as the case in the large retail outlet that was breached a couple of years ago, in fact last year, then they saw an alert come in from one of their security technologies, kind of missed it, and then 4 months later it was found during the post-investigation of that breach. It was found an alert was generated 4 months beforehand. So security teams have a number of alerts coming in. One does come in. Essentially, there's a manual analysis process that is run through via a playbook. Once that analysis has been run through and maybe that threat is confirmed, the security team is then essentially put on a bandwagon, go out, take a copy of that individual device or endpoint computer, hopefully get a copy of memory as well. Traditionally, some open source tools and computer forensic tools are used in investigation, and all of this is a step-by-step process without the ability to reach out across the entire enterprise to validate the scope of that infection once it's been investigated, and then, of course, remediate it. So typically the approach is wipe and reimage or wait on AV for an update. And so that process is very manual. It generally does take a few days at a minimum, and most of the time it's around that 6 to 7 working day mark to fully investigate a valid alert. With the automation that we provide, we're able to forensically collect data from an endpoint at the same time as the alert. So a security alert is generated, we'll reach out to the endpoint, gather data that is useful for the SOC analyst to correlate the endpoint data against the alert information and identify false positives very quickly, but also identify true positives very quickly and walk down a set of tasks that allows them to validate that threat and then hand that data off to the incident response team. The way in which the automation works, put very simply, is something happens within the environment that generates an alert through an IDS, a firewall. Those alerts can be collated at a SIM tool. If it's not collated at a SIM tool and a SIM tool is not in place, we actually do communicate and work with or partner with security perimeter tools as well. But essentially, something will provide us with an alert. And in this case, it's Splunk that'll be correlating and aggregating that data. Splunk will essentially send us an IP address, maybe a hash, could be an open port that was generated during the alert, maybe for a callback request that was identified. And what we'll do is we'll take that IP address, reach out to the target, and take a snapshot of volatile information from memory. That snapshot takes 30 seconds. It is the basis behind our threat hunting and detection tool as well, and essentially it's a list of running processes, open ports, map DLLs, and the like. Very quickly, because we'll be showing this in the demonstration, but from there, the analyst can actually identify that the executables found within the alert or the items within the alert are validated as running on the endpoint. Then they can use threat intelligence to see if those files have been seen via threat intelligence sources. And if they have not, those files can also be collected and dropped in a watch folder that allow a static or dynamic analysis, malware analysis engine to analyze those files. On the flip side, when you have an on-demand incident response and something's being validated, the incident response team do need to jump in fairly quickly. So what we do is provide a remote tool that allows you to compare machine against baselines, quickly identify outliers if needed, root out all those potential indicators using deep forensic tools. We also integrate with open source tools, which you'll see in the demonstration as well, to make the tools available to those, or to make the tools that incident responders use more available, more accessible to them, and then ultimately get to a point where they've identified each of the forensic artifacts related to that individual breach or attack. What you end up with is an optimized incident response process where every stage is automated, and those 7 individual steps that we touched on earlier are reduced down to essentially 4. So EnCase Endpoint Security will reach out, collect data as needed, present that data to the SOC analyst at the point of alert to make sure there's no degradation. A full investigation can happen remotely without the need to travel, using a full range of tools that incident responders know and love to use. And then once those artifacts have been gathered, we can search the rest of the enterprise for that immediate threat and remediate it if need be. It can take the investigation process or the alert triage process down to about 4 minutes or 3 minutes. And then the investigation process can happen in hours as opposed to days. So within a day, you could be fully investigated, remediating a positive security alert as opposed to that 21 to 36 days that was quoted earlier. And just the last couple of slides here before I hand it off to Megan. So killing the process is one of the things that we do in our remediation other than wipe and reimage, and rather than process blocking as well. So process blocking leaves that executable on the system. If it's a rat, it gives a remote access Trojan, it gives the attacker time to pivot. What we do is kill the process, surgically erase that file with a null overwrite, give you the ability to remove any persistent mechanisms within the registry, and essentially send that machine down to a trusted state and repeat that process on an hourly or daily basis. Just a brief overview of those integration partners that we do have. On the left here, any of the vendors that we support from an integration perspective. So we're focusing on Splunk today, but any of the tools listed here on the left can send us an alert where we'll immediately generate a response from across any of the 7 operating systems that we support: Mac, Windows, Linux, HP UX, Sun Solaris, AIX, and Novell NetWare. We also support threat intelligence, obviously, to give that Tier 1 analyst an ability to reduce those false positives faster. And we also integrate with IOC searching to make use of threat intelligence. And then, of course, we have the open source tool integration as well to make it easier for the IR team to go about their daily job. Of course, added with that, we have our best-in-class forensic solution that also supports and sits behind this solution itself. So with that, I'll jump over to Megan and let her introduce Splunk and run through the integration itself.
Thanks, Mitchell. All right, so now we're on to the Splunk portion. And first off, we're going to talk a little bit about what Splunk is. So at a high level, it's an extremely powerful aggregation and correlation tool for all of your machine-generated data. Splunk helps you analyze your data through both reports and visualizations. It's also highly extensible with its custom search modules, alert actions, workflow actions, and other Splunk apps developed by Splunk themselves as well as third parties. And of course, it's an excellent complement with our endpoint security product. So why did we decide to integrate with Splunk? Well, with both its free and enterprise versions, Splunk has found its way to a wide variety of companies and security teams. Splunk is really friendly with third-party integration, and unlike other tools, it's really easy to get data in and out of Splunk. So what sort of challenges did we want to code against it? Well, alert inundation. If you have machine-generated data, you're going to get a lot of alerts, and it doesn't matter how many guys you have manning your Splunk system, you still have to sift through and figure out which ones are false positives and true positives. On that note, how do we reduce the action time? Whether it's 2 in the morning or 2 in the afternoon, you're not going to get the response time that you're hoping for, which leads me directly into, well, let's automate it. It's great to have people work on things, but quite honestly, automation just gets things working more efficiently. And I really enjoy it because then we get to have people working on things that their time is actually needed for, when we can have something that can automate something that's a little tedious. So the integration itself. The background on this, last year, January 2015, I was given a research project by my boss at the time. We started getting a lot of requests about whether or not we could integrate endpoint security with Splunk. So after a little bit of research time, I made a document with all the different ways we could integrate, as well as a small program that would listen for alerts from Splunk to kick off jobs in EnCase endpoint security. So soon after that, we kept getting a few requests of other consultants saying, hey, can we deploy this somewhere else? And shortly it was deployed globally. Then a few months later, we added in the second direction. So now we're piping data from EnCase back into Splunk for re-indexing. And now that we have the whole workflow going, the Splunk integration was brought into its core debut at the end of last year with Endpoint Security 5.10. So what's the cool stuff about this integration? Like I said, bidirectional data flow, so we get the information back into Splunk. Pseudo real-time scanning, so the quicker we can get that alert, the quicker we can scan against it. It's automated. It's configured and managed in Splunk. So once you set up endpoint security to listen for those alerts, it's very set and forget, and you can change all the configuration within Splunk. And of course, it's just with endpoint security, so it's pretty much ready to go from day one. So at a high level, the Splunk integration looks like this. We have the alert that comes through our enterprise. Splunk gets the alert, and the alert is then sent to EnCase for analysis. Then EnCase goes out and searches for the snapshot that was probably configured. On that note, we can do just about anything. We can do snapshots, system profile analysis, internet artifacts. Anything that can be configured in EnCase endpoint security can be run through the Splunk integration. When that job is done, the results are written back to a CSV file, which is ready for pickup by Splunk for further analysis. So the really awesome part about this integration is that cycle we just went through is not the end-all be-all. Let's say you had a snapshot and it came back with a list of hashes, and some of those hashes were on a blacklist. You could immediately kick off a system profile and analysis for further analysis. Or what you could do is, if you felt really comfortable with it, is you could kick off a remediation to get that blacklist out from your endpoint as well as the rest of your enterprise. And of course, because this is Splunk and it's extensible to third parties, it's extremely powerful, and this integration can continue to be made better, whether it's today or in the future. So that is all that I have to say about Splunk.
Great. Well, thanks, Megan, and thanks, Mitchell. It's always nice to talk about these things conceptually, but Mitchell's now going to go through a technical overview of the Splunk and EnCase integration.
Okay, so our demonstration environment
Okay, so our demonstration environment is a dual-purpose system. We have essentially a full-scale environment running here. We have 20 different endpoints. We have Exchange servers running. We have an instance of Splunk running, and of course we have the guidance software EnCase suite of applications, including Endpoint Security, eDiscovery, and Endpoint Investigator as well. So just a little bit of information. We do have a virtual machine running inside of this. This single instance here is the machine that we'll be collecting from. You can see the machine name across the top here, IR518W. And again, we do have access to instances of Splunk as well. So let's just start off here with Splunk itself. So a typical Splunk interface, typical process would be a set of events to be identified. When those events are identified within Splunk, that will trigger a response to EnCase Endpoint Security to reach out to the named endpoint and gather volatile information out of memory and pull that data back and allow it to be accessed by the security analyst reviewing that event. Will then have data from the endpoint to correlate against data from Splunk, and it'll allow for a very easy process of validating a security event and then moving through to stage 2, stage 3 analysis as well. So how do we set up an individual event? We can do that through workflow actions. So we go to settings, knowledge, and then fields. Jump over to workflow actions, and you've got the ability to create a new action in this individual screen. We've already got one. It's called snapshot. The snapshot is essentially the main job task that's run. We can do an internet artifact collection. We can pull memory. We can do a full DFIR timeline, digital forensics timeline of everything that's happened on that system using forensics information. So no need for constant analysis or continuous monitoring. We can pull all that data back if you understand the operating system, and that's exactly what we built. But the typical go-to is the snapshot, and that's because it's 15 to 30 seconds. It pulls data directly from memory. It's a list of running processes, open ports, communications, network information such as the NIC, users that are logged in, so on and so forth. So it's a lot of information for 30 seconds worth of pull, and it's only about 500 gigabytes in size with over 5,000 different data points. So we're going to label this initiate cybersecurity snapshot. It's going to apply across several different fields. We'd normally, through an automated process, apply it to a set of event types. So one could be a C2 callback, could be malware identified, it could be dynamic or static analysis of an executable has created an alert, it could be an IPS system, it could be whatever system creating those events. So we want to make sure we list out those events. We're also going to show this action, and that's how we're going to run it today, as an event menu action. And so I'm going to run this manually, simulating that automated effect. And then how it's going to open and just details about the EnCase endpoint security solution in the background, and just information it needs to run. So we've got this dedicated to our virtual machine. Typically this would be a variable value which will be filled in by Splunk itself. And all of this will be set up by our professional services team. So they'll come in and just go through, install this for you, set this all up, work with you to identify the events, and of course they'll walk you through, do a knowledge transfer at the end. So once that's set up, we can, it'll essentially run in the background, and anytime an event has been identified, it'll automatically run through the following process that I'm going to run through manually. So we're just going to find an event here to start off with, and we're just going to pick the first one on the list, and we're going to go to event actions and initiate that snapshot. Now before I do it, I just want to show you the back-end system. So typically this interface is not used a lot, especially when a lot of the automated features are running, but I have an investigation running. It's called two-way Splunk SIM investigation. I have a set of scans that are already here, so a couple on 2 November, one a lot earlier, and we'll talk about that in a second. And then we have so we have 3 in the list, and so I'm going to run this one. Initiate cyber snapshot. It's going to reach out to the EnCase endpoint security listener, deliver the job, and again, this would be automated based on an event. We're running it manually, and it can be accessible to the SOC team as a manual event as well, if needed, in case you have an event type come in that you need the data for, but you don't have the automated event process set up. So that's set up. That should be running now in the background. I'm going to flick to my results section and just refresh your screen, and you can just see we just had a new event come in. It's in GMT time, but we can correlate that against my clock down here. So 56 or 10:58 on this clock is 5:58 on that clock. So that's the new event that's come in. Jump into it, and it's actually already finished. So 30 seconds, you can see it's got all targets finished. An alert would be generated if the machine could not be found or the IP address didn't resolve. Typically speaking, with an automated snapshot, that's never going to happen, because this alert is kicking off, or this event is kicking off within seconds of the SIM picking up that individual event, or whatever that tool is that's generating alert. So it's a really low rate of alerts if you're using the automated functionality. So now I have that finished. I can click on report, and report's going to pop up Internet Explorer and just run me through the results of that individual snapshot. Just the generate button. Now, we do have that two-way integration with Splunk. I don't have that set up, but typically speaking, what would happen is the results would be sent back to Splunk as well. Splunk will pick them up and normalize the data and list it out within Splunk itself. It'll be available within the same event as a separate tab. So that's great for the SOC analyst. Doesn't have to jump out of the tool that they're doing their triage in. I find it a lot easier to use our web interface, and it means I can pivot and jump around. So using this report that we've just run, just give you a quick overview of what's in a snapshot. So we do have processes, a full list of open files, the accounts and the users that are logged in at that machine at point in time and or available. Anything with an asterisk is actually logged in. You can see it says logged onto domain for this particular user. List of running processes. So with those processes, we do include process ID, the instance that is run underneath that executable. We do have the file path, hash values, the type of process it is, whether it's hidden or not. We can list out the child process, the parent process, and we can pivot around anything with a blue hyperlink. We can pivot around, as well as a bunch of information. And so this works on the 7 different operating systems that we support. We have a version of this for each of those operating systems. And the agent itself is useful, or is used by all of our products, but it's only a megabyte in size, so it's very tiny. Generally no issues deploying it, no BSODs coming through, a very easy deployment methodology, and can be managed by EPO as well. So you have a full list of the processes. We map them individually to DLLs, the background, but you can look at them in a different view. And then the other popular view is the open ports and the different types of communications. So we can see the state, and we can see the local IP address communicating out of, and the port it's communicating out of, and then the port it's trying to reach, as well as the remote IP it's trying to reach. And you can view that by type, go through and pull specific information about that connection, as well as pivot over to the process that's running that communication. So that's the snapshot we just run through an automated approach. Obviously we did it manually, and both use cases will be something that will be valuable to the security tier 1 analysts. And again, having this information directly from the endpoint to correlate against information coming out of the network or from log information is going to be huge in validating that something is actually happening on an endpoint. So let's actually walk through one of those scenarios. So I'm going to jump over to Firefox, and what we have is our standard overview. So as you generate events on a daily basis, most security teams have well over 100 per day come through that needs to be prioritized and analyzed, and automated events will happen. They can be generated from different types of systems. We can see we've got this integrated with all of the partner integrations that we have. So these can be filtered. They can also be reviewed as well. So from here I can say, okay, I've got 24 open that I haven't checked before. I had some alerts that were created, and it'll give me exactly the number of occurrences. And then of course I can filter down by the alerting technology, whether it was a manual request that like I just created, or whether it was actually generated by an automated partner integration, and which one that was. So I can filter on each of those as I need to. So I can flip this over to other, and it's just going to filter that list. As I want to change and alter the scope, I can just highlight everything and it'll go through and reset the data down the bottom. So we're going to do the Splunk two-way integration, and we're going to run through a scenario here as well. So let's just open that up. And we're taken directly to the snapshot that was taken after an automation sequence. So the beauty of this is the information that you get from the SIM tool, or whatever that alerting technology is, generally going to be a machine name or a machine IP address and some other bit of information. So in this case, it was a C2 callback looking for the ghost remote access Trojan, or identifying the remote access Trojan. And so the information we were given was essentially it was communicating to a remote port of 80 with a specific IP address. So we're on that machine, we've taken a snapshot, we've got volatile data. I can type in the remote port that I was given out of that alerting technology. It just happened to be source fire for that particular instance. And now we're looking at any executable that is communicating to a remote machine and over port 80. So I have a list of SVC hosts. They have the same process ID, which means that have multiple connections. Each connection is established, and we have the parent process ID information as well. So from here I can essentially ask for more information. So let's go and do that. Let's click on the process ID and get some more detail. So now we're in the process, and from here, depending on the playbook, a tier 1 analyst might go, okay, executables being validated, communicating on the port, let's push this off over to tier 2 or tier 3 or the IR team, and let them run with the analysis. So that's definitely a possibility. If you want to extend the playbook for the tier 1 SOC analyst, they can actually do a few things from here, which helps them move them down the line, help them get through those false positives faster, or identify them faster, get some more information for those true positives, and hand more information off to the incident response team or the investigations team. So first of all, I'm going back to the previous tab. I forgot to mention that this information is relevant, so we want to capture that information and maybe export it out for a logging or an incident management tool. So we can go actions, export the first 1,000 rows to Excel. That'll open up an Excel file with that data in it, and we can continue doing this just to build a list of the data that we're building. So let's export it out now, and I can add that to any sort of management tool. I'll jump back to the tab I was in. So I'm in the processes section of that snapshot. We have the process ID, we have the parent process ID, and then we just go through and look for raw information. So executable hash is good information that's pulled straight from disk during the snapshot. So in 30 seconds we're grabbing the hash values as well. But what I might want to do is just validate using threat intelligence that I subscribe to, whether or not that hash has been seen before. So I can go actions and get the threat value. Now from here we have listed last line. We also by default provide straight access to virus total out of the box if you have, and then it allows you to, I think, do 10 requests a day. If you have a subscription to virus total, it will allow you to do unlimited as well. So if the company's paying for that, then you have more. But we can integrate with any web-based API. So go and launch the get threat value. It'll pop up and just tell us it's doing that. I don't think this will actually respond because I've done it before. And it actually came back unknown. And in looking at that data, so that's the first thing we need to know. And again, we might want to export this data out to Excel. So knowing that has come back as unknown through the threat intelligence, then what we actually want to do is maybe escalate this. But again, if you want to extend that playbook, we can actually look into this a little bit further. So we'll go with the simple stuff first. So just having a look at this, we might want to have a look at what SVC, or what child processes are under this individual executable. So I'm going to slide over to View Child Processes and click the View button, and we get command.exe. Now we know that's a command prompt. You could probably guess that running out of a Windows service is probably not normal. So this would be definitely enough information for escalation. If I go back, there's a few other tells here that a trained eye might see. And if they're not a trained eye, we do have training services that allow you to be trained in this process. We have a certified forensic security responder course or certification that runs you through 2 different courses in advanced forensics training and incident response training. And we also have full forensics training as well to understand how operating systems work and that sort of like. So guidance can help you understand this stuff a little bit more. But to be honest, it's once you understand how the operating system works, it's very easy to pick up on obvious items. So we have SVC host. The information's all here. We have the hash values, and we know that it's launching a DLL because you can see the service DLL given to you. So again, very quick, very easy. The other thing worth mentioning here is we have the instance name is being pulled. That's a dead giveaway. Obviously, we know what we're looking for, the ghost rat. And then the final here, which is a little bit advanced, but very easy to identify as well, is I know this is a 64-bit system, and I know that because this directory exists, the syswow directory. And what that directory does is it's a holder for 32-bit applications in a 64-bit operating system or version of Windows. So the Windows operating system should be running SVC host out of system 32 if it's a 64-bit system, because that's where all Windows executables are run out of. If it's a 32-bit executable on that 64-bit build, it'll be running out of syswow. And SVC host, as it's a native executable for Windows, should be running out of system 32. So if it is running out of syswow, then I know that it's not the SVC host that came with the Windows version or through an update. So that is a massive indicator. Again, what I do here, capture that data through Excel, and then I can definitely escalate this if needed to the incident response team. And the final thing a Tier 1 analyst can do from here, specifically, there's a couple of things, we'll jump into those in a minute, but they can also go actions, and they can essentially collect the executable as well. So if you do have dynamic access to a dynamic or static malware analysis engine, you can essentially create a job from here that will reach out to that endpoint machine, and you just have to select it and reach out and collect the 2 executables that I have listed. So that service DLL and the SVC host instance. I just type in the machine name. You can see it in the background right here. Click this over and identify that individual machine and collect it, and the machine's not in the list. And it's simple, it probably is, I just had to make it contains. There we go. So very easy. So once that's done and collected, it'll essentially drop that into a watch folder, and the dynamic or static malware analysis engine, such as FireEye, such as LastLine, can essentially process that executable, detonate it, and see if it is in fact malicious. So that is a great handoff point to the incident response team. If you have experienced Tier 1 SOC analysts, they can dive a bit deeper. So from here we can dive into some other job types. So I just wanted to point out before we do that, The information that I was able to glean from about SVC host is available from the SANS Find Evil posters and other similar posters they have. If you don't have access to these posters, they're a great read, hang up on the wall. They're freely available at SANS or the SANS website, and this tells me how many instances of SVC host should exist, what service account is supposed to be running under, so on and so forth. So I checked those out, and it was SVC host running under service, running and winning it, so it looked good. But the DLL was obviously the key indicator, and then the folder location was another one there, especially considering our threat intelligence service hadn't identified that hash. And that's kind of normal because hash values tend to change with every new instance of malicious executables. So a lot of the attacks seen nowadays and hitting the media, essentially 90% of those attacks have, from a hash perspective and a small amount of content in that executable, are unique. So 90% of those are unique. So hash values are not going to show a lot. It's about the reverse engineering and the analysis and of those individual executables, and that's why tools such as this, with the detection size and the threat hunting, are becoming more and more common, because it provides the security team an ability to hunt for threats that are not identified or not known to threat intelligence providers. So as we get into some of the other automated approaches, so we did the snapshot that takes, like I said, 30 seconds. It gave us information about the fast user switching DLL. We know that exists on the endpoint. What this system also allows you to do is store and maintain whitelists of machines, so baselines of machines. So now that I have that fast user switching DLL, what I can do is search that machine for the DLL, and what EnCase Endpoint Security is going to do is just show me any instance of that file name that exists outside of the white build or the baseline. So I know that that DLL is not part of the gold image at this particular company. And again, another indicator, I can export that out. It gives me the folder. So again, that syswow folder, 32-bit application on a 64-bit system. And we give you the true folder path, and that's the beauty of reverse engineering the operating system to gather this data, is we gather the true information. So that's another piece we can add to the puzzle and hand that off as well. And then of course we do a full registry search through specific registry keys, and if you know again what you're looking for, so a DLL generally for any sort of malicious software will have a persistence mechanism, and again we can see there's registry paths created for this individual DLL, and we can dive in and get full details. So friendly name and so on and so forth, that's available for this individual DLL. It's even got, look at that, the parameter that it's been run under as well, and that's all available out of the registry. So again, great bit of information. It's all available through the web interface, and similarly speaking, this data again can be exported straight to Excel so that it can be added to that incident management tool and handed off to the incident response team. I think what I'll do here is also show you, a secondary piece as well. So part of those automated jobs, we can create that digital forensic incident response timeline, the DFIR timeline I was talking about. And essentially what this does is use forensic investigation methodology to pull process executions, file creations, modifications, essentially actions on a system related to processes. It pulls them out into a spreadsheet-based timeline. You can see I've got it filtered by a date, and it's got the event time, process executed, the file itself, where it exists, the hash value, whether or not it's 64-bit, any parameters added into that instance or running instance of that file, the SID that ran it, process ID, DLL counts attributed to it, number of children, and so on and so forth. And that'll run through for, like I said, files modified, files created, files running, processes running, and this will build a history of that machine over a few hour period, which is exactly what you need when you're investigating or triaging an event. So you have an event go off at 2 a.m., you get the snapshot at 2 a.m., you go back into the system and you work out, you want to build a timeline of what happened between 1 a.m. and 3 a.m., and that'll be listed out right here. So again, it's a great approach. There's no need to have a constant agent running if you know what data to look for and what data is available to you through Windows and other operating systems from a forensic perspective. And that's the beauty of having a forensic background. And we basically make it easy for you and just plot it out over a timeline. Through this process, we created an automated response through Splunk, reached out to an endpoint based on a security event. We found SVC host to be running on port 80, and that had a DLL that seems very suspicious because of the folder it was in. We collected that DLL to run through a malware reverse engineering engine, and while we're doing that, we took a look at registry keys, whether or not that DLL was in the baseline gold build, and we also could look at internet artifacts and a DFIR timeline of what exactly is happening, a real-time timeline of what exactly is happening on that endpoint. Now, if the incident response team or the investigation team does find that that's a malicious executable, or that reverse engineering engine finds it's malicious, because we have a copy of it, what we do is we ingest it and we create an entropy value. So this is a patented algorithm that Guidance created. And essentially what it does, gives it an executable score between 0 and 8. And that score represents the relative amount and type of packing inside of that executable. So how condensed it is, as an abbreviated overview. And then what we do is we search the rest of the environment for that entropy value and systematically that DLL for all intents and purposes. So just doing that, having a look at the results, here's what we found. So we found fast user switching, and that's the DLL we're looking for. We know the logical size it has is, if I'm doing my math correctly, that's 100 kilobytes. This particular instance found on the machine we found it on was 100% likeness, and it was 100% likeness because the entropy value is identical. It's the same file. There's no delta in that entropy value. There's no delta in the size, so it's the same size, same probably hash, or it is the same hash value, and we know that's 100% similar. This second file is interesting because this second file is a temp file. It is, in fact, it has a delta of 0.008, so it's only minutely different, but still different. And if you want to see how different it is, we've gathered that as being 53% different. So even though it's got 0.008 difference in the entropy value, it's actually, we've rated it as only a 53% likeness, and it has a size delta of 31 bytes. So of course the hash value is different with the size difference. But what in fact this is the temp file that spawns the DLL. So we've picked it up as 53% similar, and we'd say generally anything over about 40% likeness is worth a look. And again, from here, now that I know this temp is, I can actually collect it and run that through the dynamic malware analysis engine if I'd like, just to get validation. If I relatively know it's bad, and I know obviously that one is, I can go actions, and straight from here I can actually remediate it off any system that those executables were found on. And of course I have the original executable in the DLL and then the variant in the temp file, and we ran this across the entire estate, so we know that every other PC doesn't have something valid to look at, and what I want to do now is kill the process and remediate it. And it was obviously only found on one machine, so we just do it on the one machine. But then I can actually find the persistence mechanisms, so the registry keys, and remediate those as well. And I can schedule this to happen on a daily basis until your AV is up to scratch. So without the need to wipe and reimage, like we were speaking about a little bit earlier, I can essentially take this machine down to a trusted state, removing that malware without the need to wipe and reimage, losing no downtime or productivity for the user or the server. And that'll get you out of that hair on fire situation. So that's kind of the process we want to run through. I will state a couple extra things. If you're a little bit more technically inclined and you prefer to use open source tools as part of that investigation process, and you are part of the incident response team, then we do have this open source integration kit that comes with EnCase Endpoint Security. Essentially what it has about 18 different open source tools bundled into a graphical user interface. The beauty of this is you don't need to deploy those tools to the machine you want to run them on anymore. It uses our agent to collect the data for the tools, and it uses the interface to essentially create a point-and-click methodology rather than having to remember command lines. So PDF analysis parser, Plasso log to timelines included. You simply enter the event ID, your Splunk security event ID, and the target machine name. With log to timeline, you're looking at data that's previously been collected, so you give it a storage path. Some of the cool things, Reg Ripper, if you want to do a registry search and collection, run strings over an executable, pull out all the strings. This volatility integration is fantastic. Again, taking away the pain of all the command lines and put them all within a dynamic interface that changes as you add in your profiles and your requests for the different types of commands you want to run over them. And then the last thing we've added is the reverse shell. And so this is actually pretty cool. We only added this a couple months ago, and this allows you to essentially run a command prompt on a remote computer using our agent, of course, but using that you can actually batch isolate an endpoint, restrict its communications to anything but our agent, and run your full investigation, knowing that individual machine can't talk out on any other port but our default or whatever that port is that you've set for the EnCase agent. So that's kind of cool. And then we've also implemented some scripts. So this typical incident response approach, you have the open source tools you know and love fully available in the tool, and of course you also have our complete computer forensic remote investigation technology as well, where you can reach out to a given endpoint and run a full investigation remotely without need to essentially take a full disk image. So between this, you can capture the full memory, do a full machine investigation. We just added these pathways in that, if you've never used EnCase before, it walks you through, how to create a case, how to add that preview in, how to look for files, and what to, so on and so forth. So very easy, simple to use, and then you bundle that with a UI to open source information for the incident response team or tier 2, tier 3 analysts, and then you've got the full web interface for your SOC tier 1 analysts available there. So that was a quick run through. Hope you enjoyed it, and thank you.
Okay, so just a quick wrap up. EnCase endpoint security does have the capability to detect anomalies of process and user behavior through the detection functionality that we didn't show in the demonstration. But the process we did run through is the process of automating from Splunk. We can automate through other tools as well, but that automation kicks off a response process that EnCase endpoint security initiates at the time of the alert, returning the data that's valuable for the security team when the alert happens rather than when they're investigating the alert. Ultimately, that happens in seconds, and then we walk through a process of validating and verifying a potential threat, remediating that threat through the web interface available to the SOC team, but also we touched on some of the investigative tools that are available to the incident response team for deeper analysis as well, ultimately ending up in about a 3 to 4 minute triage analysis process. Probably with the full investigation with the IR team, you're down to a couple of hours from potentially weeks or months. And then the ability to recover surgically using an erasure technique by killing the process, removing the file, getting rid of the registry persistence mechanism, and then scheduling that to keep you covered until your AV is up to date. So thanks everyone. That was EnCase Endpoint Security, and that is one of our suite of products. So with that, I'll probably hand back to JJ.
Great. Thanks, Mitchell. So at this time, we'll be taking questions. If you have a question for Megan or Mitchell, please send it to us using the Q&A window on your screen. So the first question that we're going to deal with comes in from Sean. And Sean asks, can we see changes to other executables under SVC host?
So yeah, I can take that one. Absolutely, you can. So we provide the process ID as well as the parent process ID. If we pivot over to the parent process ID, we can see anything that's spawned within SVC host or any other executable. There's also a link to the right, I don't think I showed in the demonstration, which is child processes that are spawned by SVC host as well, and you'll get those individual processes as well as any parameters or tasks that are run from the execution of that process. Thanks, Sean.
Great. And next question is from Audrius, and it says, does Snapshot rely on Windows API or raw memory data?
So the Snapshot does use some elements of the API, but I would say 90% of the Snapshot is reverse engineered by the guidance engineers, and that Snapshot works across not only the versions of Windows dating back to 3.5.1, but also the other operating systems we support as well. So it is reverse engineered by us, and we've had to maintain that. And that's to evade any issues where if the endpoint is under attack and potentially some data could be obfuscated by the attacker. So we want to make sure we reverse engineer the information ourselves and not rely on those APIs.
Great. Next question is for Megan. And the question is, does EnCase send data back to Splunk?
Yes, it does. The great thing about the Splunk integration is that it's bidirectional, so when the EnCase job is complete, the results are written to that CSV file so that Splunk can re-ingest it.
Great. Next question is from Charles, and Charles asks, what were the operating systems mentioned that EnCase can be deployed on?
So as an application for installation, it's a Windows application. The agents themselves, they can be deployed on Mac, Windows, and Linux as the main three, as well as the server variants, which are HP-UX, IBM AIX, Sun Solaris, and Novell NetWare.
Thanks. And for the sake of time, we'll take one more question. This one comes in from Martinez, and Martinez asks, why Splunk and why not HP ArcSight or IBM QRadar?
So we did glaze over that information fairly quickly. We do allow integrations, or we do have integrations with a number of SIM tools, HP ArcSight and IBM QRadar, as well as obviously with Splunk. We've been beta building other integrations such as Intel's McAfee SIM as well. We also take essentially integrations or requests from APT detection and sandboxing tools such as Palo Alto's Wildfire, Lastline, and FireEye. We also integrate with SourceFire, Cisco's IPS, and we also integrate with Blue Coat Security Analytics, the network analytics tool as well.
Great. Thanks, Mitchell and Megan. So we'll go ahead and wrap things up. Thank you to all our listeners for taking the time to attend this webinar. I hope you found it a helpful and informative experience. Thanks again to our presenters, Megan Gardner and Mitchell Bazina, for sharing their expertise with us today. Once again, please don't forget to provide us with your feedback on today's webcast using the survey populated on your screen, and feel free to download the available resources that are in today's webinar that we have provided. For more information on the topics discussed today, or to speak with Guidance Software, we invite you to reach out to our solution specialists through one of the following. You can email us at experts@guide.com. You can visit our website, guidancesoftware.com, or you can call us at 866-229-9199. Thank you for watching.